Hello friends, today we are going to see how to find out the in-order successor of a node in a binary search tree. So let's see, this is the binary search tree and we want to find out the in-order successor of any given node in this binary search tree. Obviously it is very easy if we know the in-order traversal of that binary search tree, but it is not feasible to find out the in-order traversal of a binary search tree just to find out the in-order successor of a single node. See, what I mean is that if there are thousands of nodes in this binary search tree, and if you want to find out the in-order successor of a single node or of only one node, then just for finding out the in-order successor of that one node, it is not feasible to traverse the whole binary search tree which is having thousands of nodes and then find out the in-order successor. So we should have a mechanism to find out the in-order successor without finding the in-order traversal. Okay, so without looking into the in-order traversal, today I am going to tell you the mechanism to find out the in-order successor of a node in this binary search tree. So let's see how to do it. Now there are some cases, and the first case is if that node has the right subtree. See, suppose you want to find out the in-order successor of 16. Okay, so as you know, 16 has a right subtree, means it has a right child. Okay, as the right child is present, that means there is a right subtree for this node, that is 16. So if that right subtree is present, then find the least value node from that right subtree. So as you know, in a binary search tree, the right side contains all the values which are greater than the node. So in the right subtree of 16, in this right subtree, there will be nodes which are having greater value than 16 because it is the right subtree of 16. Okay, so if we want to find out a value which is immediately next to 16, means as it is the in-order successor, means after 16 the node which comes next to 16 in the in-order traversal should be the in-order successor, right? Because the in-order traversal of a binary tree represents the sorted order of a binary tree. Means if we sort all the values in ascending order for this binary search tree, that represents the in-order traversal. You can see here, this is the in-order traversal, but we are not going to use this in-order traversal. We are going to see this in-order traversal only for verification of our answer. We will just verify our answer here. So see, if you just concentrate on this, then for 16 these values are the next values in the in-order traversal. So what will be immediately next to 16? Means in the sorted order, what will be immediately next to 16? So that will be the least value in this subtree. The least value in this subtree. So what is the least value in this subtree? See, 40, 45, 35, 32, 30. So 30 is the least value. So after 16, 30 will come in the in-order traversal. So that is the in-order successor. Okay, obviously if you consider only this as a tree, just forget about everything else, just consider this is the tree. Okay, now as this is a binary search tree, the leftmost node will always have the least value for that tree. Means for this tree, this is a subtree here, but we are considering it as an independent tree. So if we see it like that, then the leftmost node will always have the least value, because in a binary search tree the left part of any node contains the value which is lesser than that node value. So if you go to the leftmost node, that will be the least value. So that means for a node which has the right subtree, then in that right subtree the leftmost node is the in-order successor. So here 30 is the in-order successor. Okay, let's verify. See, in this in-order traversal, which node is next to 16? That is 30. So our answer is correct, means 30 is the in-order successor. Now, how to write a code for that? So I have written it here. It's very simple. See, now I read this code. If p points right is not equal to null, means if the right subtree is present, means if that node p has a right child. See, if p points right is not equal to null, means the right child is present. If the right child is present, we go inside. See, means we jump to the right, we go to the right subtree. Here, see, temp equal to p points right, means now we jump to the right subtree. So temp will be pointing to the right child of 16. Okay, and inside, as I have told you, you have to go to the leftmost node. See, while temp points left is not equal to null, means you have to check where is the leftmost node. See, for 30 the left child is null, means this is the last node in the left branch of this subtree. See, that is what I am checking. I am going to the left of temp until the left child of the node is null. See, so for 40, see, temp points left is not equal to null, so go to left. Temp equal to temp points left. Again, temp points left is not equal to null, so go to left. Again, temp points left is not equal to null, so go to left. Now temp points left is null, so stop here. Now temp points left is null, so stop here. And this is your in-order successor for the node P. Okay, in this way we have found out the in-order successor of a node, and then we print that in-order successor. So this is the first case. Now let's go to the second case. So let's go to the second case now. See, the second case is if that node does not have the right subtree. Means, for example, the node 37. See, the node 37 does not have the right subtree, or the node 15 or node 10. This node does not have the right subtree. So this is the case. So it is written here, if the node does not have the right subtree, then search that node P from root, and while searching, the node from where we take the last left is the answer. So I will tell you what is the procedure. I will explain that sentence. See, if you want to find out the in-order successor for 37, so let's search that node inside this binary search tree. Now you know how we search. See, take this node 37, take this data, and let's start from the root. Okay, now see, 37 is less than 50. So let's go to the left side, because 37 is less than 50, so it should be on the left side of 50. Now 37 is greater than 16. So let's go to the right side of 16. Now 37 is less than 40. So let's go to the left side. 37 is greater than 35. So let's go to the right side. 37 is greater than 36. So let's go to the right side. 37 is equal to 32. So we have found out our node. So this is the searching procedure. Okay. This is the searching path. See, I will mark this path. Right. Now, in this traversal, in this path, what is the last left? Means, how many times we have taken the left turn? See, this is the first left. Means we went to the left child for first time. Then this is right. See, this is the second left. This is the second left. Okay. Then we went to the right child. Then we went to the right child. So totally there are 2 left turns. Okay. So what is the last left? Means what is the latest left? The second left. So this is the last time we have taken the left turn. Okay. So from which node we have taken this left turn? See, from where we take the left. So from which node we take the left turn? From 40. From 40 we took this left turn. So 40 is the in order successor for 37. That is the logic. Now see, is it correct? Yes, 40 is the in order successor of 37. So now I will tell you why this method works. See, as 37 does not have the right child, so we cannot go to the right subtree, right? That means the in order successor is some ancestor node. So for 37, the node which is immediately next to 37 will be the first node which is greater than 37, right? The first node in the ancestors which is greater than 37. We have to find out the first node. So let's take it in reverse. See, from 37, let's go to the ancestor. See, parent of 37 is 36. But it is less than 37 because it is the right ancestor. So as it is the right ancestor, it must be less than. Again go to the ancestor of that node. So again we go to the ancestor, but again it is the right ancestor, so it must be less than 37. See, in this branch, if we go in reverse like this, obviously the nodes will be less than 37. Okay, but at 35, the parent of 35 is on the left ancestor side. See, for 35, 40 is the left ancestor. Means what? 35 is the left child of 40. Okay, that is what I mean. See, here right ancestor means what I mean? I mean that 37 is the right child of 36. Again, 36 is the right ancestor means 36 is the right child of 35. And for 35, 40 is the left ancestor. Left ancestor means what? 35 is the left child of 40. That is what I mean by these terms. So obviously, as the right ancestors are less than 37, the left ancestor is the first value which is greater than 37. The first left ancestor in this path, the first time when we take the left ancestor, so that left ancestor is the first value which is greater than 37. That is what we want. We want the first value which is greater than 37 in this in order traversal. So we conclude that 40 is the in-order successor. But this is a big problem. Why this is a problem? Because we don't have any link to go to the parent of a node. See, the structure of the node in binary search tree is there is a left pointer and right pointer. There is not a parent pointer. There is not a parent pointer. This is not present. How will we go reverse? This is the problem. We cannot go in reverse. So we apply an idea. So what we say, while going in reverse, we check for the first left ancestor. Okay. So let's do what we can do. So let's search that node from the root. Okay. And mark that path. Let's search that node from the root and let's mark that path, and that is what we have done. We have searched the node from the root and we have marked that path, and in that path the last left is the same as the first left ancestor. See, in reverse we say as the ancestor, so we say first left ancestor. But that is the same thing as the last left child. See, this is the first left child in this traversal, this 16, and this is the last left child. Okay, so the node from where we went to the last left child, means the node from where we took the last left turn, is the same node as the first left ancestor. So as we can search the node, as we know the code for searching the node, we just apply an idea and we find out the last left turn, and we take the node from where we take that last left turn, and we conclude that node as the in-order successor. So that is the reason. Let's do it for 81. Okay, so let's search 81. See, it is greater than 50, less than 90, greater than 80, less than 82. Okay, what is the last left? See, this is the first left and this is the second left. So the last left is this. Okay, from where we took this last left? From 82. So 82 is the in-order successor for 81. See here, 82 is the in-order successor. So our strategy works fine. See, for 87, what is the in-order successor? Let's search. See, 87 is greater than 50, less than 90, greater than 80, greater than 82, greater than 85. This is 87. What is the last left? Last left is this. There is only one left in this path, and that is this left. This is the last left while searching 87. So 90 is the in-order successor for 87. Let's take it for 45. Okay, let's do it. Now 45 is less than 50, greater than 16, and greater than 40. Okay, and greater than 40. Right. So what is the last left? See, this is the first left. Again there is no left, so that means this first left is the last left. Okay, there is only one left, and that is this left. So this is the last left. So 50, from where we take this last left, 50 is that node. So 50 is the in-order successor. So let's check it here. 50 is the in-order successor of that node. So this is how we find out the in-order successor of a node. Let's take one more example for case 1, the node which has the right subtree. Okay, so let's take some case. Let's take 35. Okay, we want to find out the in-order successor for this node, that is 35. Right, now see, how do we do that? Does it have right subtree? Yes, it has a right subtree. It has the right child. Okay, so let's do it. What we do, we jump to the right node, and in that right subtree we go to the leftmost node. right? We jump to the right node, and then in that right subtree we go to the leftmost node. So let's jump to the right subtree of 35, that is the right child of 35 is 36, and let's go to the leftmost node. See, there is nothing on the left, that means this is the leftmost node, right? So if there is nothing on the left for the right jump child, means the right child of this node is 36 and there is nothing on the left, so that node itself, that is 36, is the in order successor for 35. See, 36 is the in order successor for 35. So this is how you can find out the in order successor of the nodes. If you have some questions, you can ask me the questions in comments and you can tell me to find out the in order successor. I will collect all the questions and I will make another video on many complicated examples of finding out in order successor. Thank you. Hey friends, please subscribe to my channel as I post algorithm videos every day. And if you want a video on any particular topic, then please mention in the comment below. Thank you.